In this video, I would like to talk about simplifying trigonometric expressions. The goal of simplifying a trig expression is to attempt to express it in terms of a single trig function or maybe even a constant. This requires creativity to try rewriting trig expressions in different ways. It requires familiarity with the common identities. These form the rules of the game. And it also requires some knowledge of algebra, being able to combine various rational expressions, for example. Here are some tips that I have before we look at a couple of examples. Everything in simplifying trig expressions depends on using the identities. Here are some of the common identities that we've already presented and looked at for trigonometric functions. We're going to be using these and a few more all the time as we simplify trig expressions and later as we prove identities. Second, you can try rewriting the expression in terms of sine and cosine. Sometimes that is helpful to see what factors or powers of sine and cosine are present in the expression. That can give you a path forward. Third, because many of these identities involve fractions, we're going to end up using properties of rational expressions to combine fractions and express them in lowest terms. So we need to recall everything that we've learned previously about working with rational expressions or with fractions. Let's try a couple of examples. If I want to simplify cosine x plus tangent x sine x, I first might rewrite this in terms of sine and cosine. So this is cosine x plus sine x over cosine x, using an identity for tangent here, times sine x. Or you could say this is cosine x plus sine x squared. Now we typically write that as sine squared x over cosine x. And let's consider what we're combining here. I have a whole expression, cosine of x, and then I have a rational expression with a numerator and denominator. We can combine these if they have the same denominator. So I'm going to take the first expression and I'm going to multiply by cosine in the numerator and denominator. We will then write this as cosine squared x over cosine x plus sine squared x over cosine x. The purpose of doing this is to get the same denominator in both of these fractions so that they can be added together by adding the numerators. Now we have cosine squared plus sine squared over cosine x. Well, if we stop and think about it, cosine squared plus sine squared x looks like one of our identities. That is equivalent to 1. This is equal to 1 over cosine x. And if I want to write this as a single trig expression, no fractions involved, I would call this secant of x. So we started with cosine x plus tan x sine x, and we ended with secant of x. This is the simplified trigonometric expression. Let's look at one more. I want to simplify secant x minus cos x over tangent x. Once again, it may be helpful to rewrite everything in terms of sine and cosine so that we can see what we are working with. This is 1 over cosine x minus cosine x divided by sine x over cosine x. This is a complex rational expression. I have some fractions inside fractions. One way to simplify a complex rational expression is to take the numerator and denominator of the larger fraction and multiply by an amount that will clear or divide with the denominators of the smaller fractions. Notice that both of these denominators are cosine x. So I'm going to multiply everything in the numerator and everything in the denominator here by cosine x. What do we get? Well, this cosine x distributes to two different terms in the numerator. And first I get cosine x over cosine x minus cosine squared x. In the denominator here, I have sine x cosine x over cosine x. Now the purpose of multiplying by cosine x is that it divides with these denominators. This first fraction is equal to 1. Cosine x over cosine x is 1. So I have 1 minus cosine squared divided by sine x. Here again, cosine x and cosine x divide out. Now, if I think about the fact that on the side, let's consider that sine squared plus cosine squared equals 1. Here is the Pythagorean identity as we know it. I could rename this as sine squared equals 1 minus cosine squared. Or alternatively, I could have also said cosine squared equals 1 minus sine squared. These are all just different forms of that Pythagorean identity. The form I would like to use is the second one, because I'm recognizing in my expression we have 1 minus cosine squared x in the numerator. And I can replace that with sine squared of x. So then my problem becomes sine squared x over sine x, and that is just equal to sine of x. We're dividing a common factor of sine x. So the complicated looking expression that we began with is equivalent to sine of x.